All right, SecKC, let's hear it. Let's hear it for SecKC. That was terrible. Let's hear it for Bill. You guys like me, hey? Yeah, all right, yeah. Ooh, now that makes me feel good. All right, so hey, I want to introduce our first speaker, but I have a little bit of a story. So I went to Dave Cochran right over here is going to be our first speaker, and I said, what do you want me to say when I introduce you? And he's a very humble man, didn't want me to do much. So what I did is I went on the internet. And I Googled Dave Cochran, Kansas City, so I could give, so I have a little bit of your background, sir, so I could give you, a good story. And what I found was a very heartwarming story. I found that we are in the presence of a celebrity. It turns out, in January 2019, a homeless man driving a car with just trash bags for windows was driving to the Chiefs game. And found a car pulled over on the side, and there was a Chiefs player who was stuck, and Dave Cochran pulled that man out, not knowing that he was a Chiefs player, and sent him on his way. So, sir, I realize that's not you, but there is another Dave Cochran. And when I run into that man, I'll shake his hand.
I am Minnesotan. It's an easy mistake to make.
Anyway, I do want to give you a good proper introduction. So Dave Cochran here, he is. We were just talking earlier, and if you have kids that are into building robots on something, after the talk, come and meet him. He's a coach for the World's Lego League, and they made it all the way to the finals. In fact, I think they won. They brought home the trophy. I saw the championship. So anyway, with that, let's hear it for our first speaker of tonight, Dave Cochran.
Check. Yeah, he turned the mic off, which is just fantastic of him. Thanks, Bill. Appreciate that. All right, so this is My Users Can't InfoSec, and it's everybody else's fault but mine. A couple things before we begin. First off, font choice. I am intentionally using Comic Sans for two reasons. Reason number one, it is proven to be more legible to people with dyslexia and other similar learning disabilities. Reason number two, fuck you, it's my slides. This talk is not going to be very, very technical. It's not going to be super fun, super exciting. There's not going to be anything exploding, I hope. It's also not meant to be an indictment of any one person in the room or even any community in the room, so much as kind of a, hey, we could probably be doing this different and better, and maybe we should. Which is what this talk is. I'm getting ahead of myself. How y'all doing tonight? I'm not nervous, you're nervous. So without further ado, let's answer Johnny the tackling Alzheimer's patient. Who am I? Anytime you'd like to go forward. Yay, technology. You know what, we're just gonna do it this way. Or not. Why are you? Technical difficulties, 1 second. Yay, Patch Tuesday. You know, I swear to God, I did rehearse this. I'm just.
Gods are not with you today.
No, they very much are not.
Do it live!
I mean, I could, but it wouldn't be nearly as fun. Give me just a second, folks. Sorry about this.
Control-Alt-Delete.
That's what I did.
Use a Mac.
No. Give me just a second or three here. See, this, folks, is why you want to use new technology and not the old shit. There we go. Give me just a moment to get this loaded back up, and we'll be on our way. I promise I can even start from the right slide. Yeah, like technology's always worked for all of you. Shut up. Go down to
Well, he's working on his IT issues. Let's see some hands. This is your first time at SecKC? Let me see some hands.
Oh, right here.
Oh, we got one right here. All right. Hey, why don't you yell when you got that going? Hello,
It's going.
sir. What's your name?
It's going.
Tyler, who brought you to SecKC? Make sure. I
No.
saw this slide already.
What's the worst that could...
So, you brought Tyler to SecKC. Good job, man. I'll buy you a drink. You too. All right, let's give this a shot. Oh, he brought him too. All right, well, hey, actually, Dave, I've got a little bit of a admission here. So if you guys don't know, we have here a little tradition, although I'm wondering if we should maybe get past that first slide before we give this thing tradition. Anyway, if it's your first time speaking at SecKC, you get a...
It's not a blowjob, right? He stole my line. All right, so I promised I'd start on the right slide, so maybe we should actually do that. So, answering Johnny the Tackling Alzheimer's patient, who is this guy anyway? I have an associate's degree in computer forensics. I have a bachelor's degree in computer forensics. I also have over a decade in retail, which, don't do that. Just don't. I am currently an interface engineer in a big healthcare IT company in the local area that is not in any way, shape, or form responsible for sponsoring or even in most cases aware of the fact that I am doing this tonight. I can neither confirm nor deny that, sir. All right, so the whole point of this talk is that we in information security are not really good at getting people to do the InfoSec things, and we can prove that by the fact that we had, how many slides was it with the news, like 5,000 or something like that? So, I'm not stepping back, you step back. So, there's a couple of reasons that this is a recurring, consistent problem that I have found with, a few Google searches and way too much time on Twitter. First off, logic is not nearly as intuitive for people as we want to think it is. For example, this is from August of 2017, July 2017. Then Prime Minister Malcolm Turnbull of Australia was asking a bunch of companies for some backdoors in their cryptographic algorithms. And they said, we can't give you a backdoor and still have it be secure. It's mathematically impossible. It would be against the rules of mathematics. To which he replied, well, it's great and all, but in Australia, I'm not doing accents because you don't want to hear that, trust me. It's great and all, but in Australia, the only laws that apply are the laws of Australia. Because that's a thing. So there's that. And then there's the fact that people are really bad at computers. And there's a bunch of people in the audience right now, sysadmins and help desk folks, are going, duh. But no, really, people are not good at computers. A couple examples here. This is presented without comment. The SecKC is a nonpartisan organization. The presenter's views do not necessarily, et cetera, but Donald Trump refuses to use a secure landline because he really likes the iPhone for his tiny hands. Cyber is hard. You are completely correct. Who here knows a guy named Deviant Olaf? All right, more people than that know Deviant. Come on.
I know Deviant.
Okay, there we go. So a couple weeks ago, months ago, whatever's ago, I forget when I made this slide, Deviant did this. Deviant went to send a sexy Snapchat picture to his wife, and he dropped it in a company Slack instead. He claims it wasn't too revealing. I believe he's still employed, so he's probably right. But I mean, if somebody like him, who's basically a red team celebrity, can still fuck this up, there's not really a lot of hope for the rest of us. So, here's the meat of the presentation. This is where if you're taking notes, you're going to want to get your highlighters, you're going to circle stuff, underline everything. This was a study done by the Organization for Economic Cooperation and Development, which is a club of industrialized countries. They asked questions of 215,942 people in 33 countries between the years 2011 and 2015, with at least 5,000 people in each country. They graded people based on their responses to this test, which I'm going to get into the details in a second, on a scale of 3 to 0. Level 3 would be if you were able to complete the test they were given. You want to know what percentage of the emails sent by John Smith last month were about sustainability. If you could get that answer, you are in the top 5% of computer users in 33 countries. Okay?
Hell yeah!
Woo! All right, level 2 would be the task given. You want to find a sustainability-related document that was sent to you by John Smith in October last year. That's another 26%. Level 1, find email from John Smith. That's 29. I should point out, by the way, these are the OECD average scores that I'm showing right now. We'll do the US ones in a second. And then the sub 1 level is delete this email. And that's 14. Now I gotta be honest, I kind of lied. There is another level to the scale here. The people who just can't use a computer. Just straight up, I don't know how to use a computer. And yeah, that's another 26%. So on the global scale, 40% of people are at or below the level of computer user where delete this email is an achievable goal. People are not good at computers. I promised the US scores, here they are. We're a little bit better, arguably. We have fewer people who can't use computers at all. But if you notice, the top 2 categories are basically the same. I think there might be a percentage point or 2 difference, but by and large, they're pretty much the same. So I started thinking to myself, you know, I've got these 2 degrees, granted they're sequential, but I've got these 2 degrees in computer forensics. What kind of things do I have trouble with? What kind of things make me pause and go, wait a second, should I be doing this? I don't know. Advancing slides is really tough. You're very clever, have a cookie. So I came up with a bunch of things that don't actually help users, but that we think help users. For example, this. I can barely delete an email, but this is totally comprehensible to me.
Where's the OK button?
I tell you, but they throw me out. I'm pretty sure this screenshot's from Firefox, because that's about all I use. And it's just saying, you know, hey, the security certificate has expired. You can go forward if you want to, but we don't recommend it. And I said, okay, that's great, Firefox, but Firefox, you don't have the best track record with security certs and the keeping up to date thereof. Now that shot's going to your heads, not mine. But security certs in general are a personal peeve of mine because I suck at updating CAs, at getting the good certs and not using the bad ones. Every time I try and update the CA, it takes me like 3 or 4 tries. I usually fuck it up each time, and then I have to go either find like a 20-minute YouTube video and learn how to do it and still fuck it up once or twice, or get a friend to walk me through it. And I'm arguably in the target audience for this kind of thing. Admittedly, I don't do security stuff on the daily basis, but I am arguably still in that target audience. This should be the kind of thing that I am at least okay at. And I will grant, absolutely grant, that it should not be an easy thing to do, right? We don't want people going in and double clicking on something and all of a sudden they have all the security certs ever, because that way lies bad. But it could still be a lot easier to do, and nobody seems to be caring to take the time to make it easier for anyone at all. It was hard for me, why should it be easy for you? Fuck that attitude, man. Other things that don't help. This is a prominent InfoSec person who I will not name because I did not get their permission to use them as an example of the bad. I recognize that the topic of the tweet has fuck all to do with InfoSec, generally speaking, but if I am a user who has trouble deleting emails, which as previously established is at least 40% of the population, and I see this, and this person is in charge of security at my organization, I don't feel confident going to them and saying, I might have done a bad, can you help me? That seems like a really, really bad idea to me all of a sudden, because this person has clearly expressed that they don't really care to educate or to help or to teach, at least based on this one tweet. There are many more from the same person that display the opposite, but I might not have access to that. I might not have visibility to that. I might not know how to find those other tweets because I have trouble deleting email. All right, who remembers January 2018?
Like it was yesterday.
Like it was yesterday, says the guy in the corner. Thank you, guy in the corner. I appreciate the assistance. Something very, very fun, I say fun incredibly wrongly, happened on January 13th of 2018. A whole bunch of people got a text message, if you lived in Hawaii, that said, hey, North Korea just shot a bunch of nukes at you. Get to a shelter or you dead. It turned out to be a false alarm, but nobody knew that for a good few hours of terror and panic. Because, and here's why this happened, that's the interface that caused the alert to go off. Actually, I'm kind of lying. That's the new version of the interface. They added a link. The red link is what they actually clicked. The yellow link is what they should have clicked. And the green one at the top is the new one that they added so that this doesn't happen again. Raise your hand if you think that there was any sort of, are you sure you want to send a get the fuck out message to everybody in Hawaii right now button. Of course not. Oh, and there's another reason. Oh, by the way, HIEMA is the Hawaii Emergency Management Agency, in case anyone cares. There's another reason that the panic went on for far longer than it needed to. The governor couldn't remember his Twitter password. There are opportunities everywhere, is the takeaway that I'm trying to get at. Now, I mentioned at the very beginning of this that I've got over a decade of retail experience, which I still don't recommend. But I mention that for a reason. This is the part where I'm self-deprecating. When I was working retail, one of the things that I did is I would sell electronic stuff to people who had no fucking clue how to use it. They would come in and they would say, I need the camera with the gigapixels. Can you be more specific? No! Okay, let's talk. I'm not gonna stand here and tell you that anyone that I sold a camera to has ever been featured in National Geographic's, annual best pictures of the whatever compendium, because that would be bullshit. And while I do tell a lot of bullshit, that's not something I'm willing to go to. But they did at least learn something. They walked out confident that they could turn the machine on and use it for its intended purpose, and maybe even do some neat other stuff with it or show off some features to their friends. Because I would talk to them. I actually got in trouble for talking to people too much because, no, you can't be sitting there talking to the customers. You have to make the sale and then go back to whatever you were doing. Talking to the customer is what I was doing. No, not that, the other thing. Again, don't work retail. It's not, but do maybe because it helps you learn how to talk to people, which I think we can all agree not all of us are the best at. I made it funny. So how do we get past this particular hurdle? How do we get people to listen to us and do what we want them to do? Well, first thing that I can think of is that we need to work on our messages. You don't want to use the same super in-depth technical explanation when, great Uncle Harry comes up to you at Thanksgiving and says, hey, so tell me about this here two-factor something that you would use with the person sitting next to you tonight, because great Uncle Harry doesn't know shit from shit. Similarly, I thought this was a really, really good quote, so I put it on the slide. Just gonna let you read that while I take a drink. You want to make sure that the people that you're giving a message to are getting a message that they can use. The C-suite is different from peers, is different from relatives, is different from your pet, is different from et cetera, et cetera, et cetera. What else can we do? Well, better communication and better tools, which are both really easy to say, I completely acknowledge and own that, and not necessarily easy to do, but I mean, come on, security certs. But I mean, most of us probably aren't even trying when 40% of our users have trouble deleting an email. I'm going to keep hammering this point because it's a really, really good point to hammer. One thing that I've noticed personally is that a lot of us tend to think that good communication means precise communication. And that's not necessarily going to be the case all the time or even most of the time. Precise can be good, can be helpful, but a lot of the time it just gets people confused, especially if they are the kind of people that have trouble deleting emails. They don't care about the difference between SHA-256 and SHA-512, or SHA-128, or whatever else. They just want to know how to not get their shit fucked, which is a completely fair goal to have. So there's going to be some counter arguments, I can already tell. People are going to come up and they're going to say, okay, but how do I make them understand why we need them to do this? And I'm going to respond right now, in advance, have you tried talking to them? Have you tried listening to them? Because a lot of times the questions that we think we hear are not really the questions that people actually have. The best question, the best response to anything that someone comes up to me and asks me for information on that I can think of is, show me what you mean. Because we've all had somebody who came up to us and said, the computer doesn't work. Okay, what do you mean by that? And it turns out that they were just having trouble getting to the right homepage. Or that their monitor was unplugged. Or that they couldn't print because printers are, the devil's handiwork. But if you gotta actually understand what they are asking before you can answer their question and help them progress. And if you can't delete an email, you might have trouble explaining what it is you mean quickly and concisely, and for all you know, the computer actually is broken. But you have to ask the right questions. Another counter argument people might bring up is, how do I get them to do what I say? Well, you could try talking to them. Again, people are willing, for the most part, to learn and to adapt and to use new skills, but it's a lot easier to get them to do that when you give them a reason to do that they can internalize. Because we said so is not a great reason. Who here has seen the Correct Horse Battery Staple XKCD? I know there's more people than that. I showed that to my mom last night because she was very, very proud of her 10-character uppercase, lowercase numbers and symbols password that she used for website. And I had to tell her that doesn't necessarily make it secure. Here's the thing. She texted me this morning. She said, okay, you know what? I completely understand what you were saying. That was a very good explanation. You gotta meet people where they're at, not where you want them to be. You're not the quarterback lobbing the football to the receiver, you're handing it off to the runner. And then, of course, well, why should I do any of this? Why do I care? Because we're in information security for one of two reasons, possibly both. Reason number one, paycheck. Reason number two, because you want to help people. Ultimately, like maybe that's not like, I'm gonna go into work today and help people. But that's the reason that we went in there, a lot of us, is we want to make the user's experience better. We want to make people safer. We want to keep shit from getting owned. That's helping people. That's why we're in this. That's why you should care. So the key takeaway here, you are in fact at least a teeny bit at fault for the fact that your users can't InfoSec, but you can help them get better if you really, really want to. I mentioned earlier, I work for a major healthcare IT organization, local, and most of my clients, most of the people I talk to are doctors and nurses. I don't want my doctor to be an information security professional. I want my doctor to be a medical professional. When my doctor and nurse clients call me up and say, hey, this thing isn't working, what the hell? That's okay. It's good in my mind that they aren't 100% familiar with all these things and that they need help understanding them. And being doctors and nurses are probably not that dumb, probably. There are exceptions, but probably. But they're able to learn, they're able to adapt. But that shouldn't be their focus. That's our focus. That's why we have the jobs we do. And then, just the last bit here. I saw this the other night. I thought it was a great message. You can fight your peers or you can work with them, but it's easier when you work with them. I've been Dave Cochran. This has been my presentation. Y'all have a great night. I turned it off for you.
Maybe I encoded it wrong. You losing weight?
I'm trying. Working on it.
Looking good.
Thanks. How long are you gonna go?
15, 20 minutes.
Okay.
Or maybe I'll pull a Seinfeld. 5, 10 minutes.
Yeah. Okay. Anything you want me to say, or just make up whatever I want to say?
Oh, make it up.
Okay.
It's good. I mean, watch this. Here's my intro, all right? This is actually not a deep dive. We're going to stay right on the surface like this guy. Everybody knows
you?
this one. No. Everybody knows that one. Right? So this is an introduction. Don't haggle me. I'm just going right across the surface.
Okay.
So,
Do
yeah.
you not want me to heckle you?
No, go ahead.
Okay. So I asked.
It'll probably throw me way off, but I need to
All right, give me that mic. All right, we got about 5 minutes, but I thought I was going to start real quick. I'm going to ask some trivia questions here. Who's ready for some trivia? All right, how many long lifers, SecKC lifers, do we have in the house? Oh, we got a few. Got a few. All right, who can tell me where was the first SecKC held? No, I think I heard it over here. It wasn't Gertz. It was Coaches. We got it. Coaches. All right, where is SecKC currently held? Yes, it is the hearts and minds of all that exist. That's right, Caleb. That's right. Good job. All right, let's see. How many locations has SecKC been held at? 5. 5. The answer is 5. Kansas is our 5th location. And we're never leaving! All right. What is the correct way to pronounce SecKC? That's right. That's my favorite trivia question. Who came up with the idea of SecKC and where? Well, that was a very, wow. Were you part of that? No. Oh my gosh, that's the next one. Okay, who came up with it? That person was Alex Lauerman on a flight back from DEF CON. It was DEF CON 14, I think. All right, so who came up with the idea of SecKC? That's right, it was me. It was Bill Swearingen. That's right. What are our bartenders' names? Give me one or both. What? I heard one. Alex, that's right, it's Alex and Bill. It's actually Cat. Well, it's Cat. We only have one. I don't see her. All right. Oh, this is a good one. What is the first name of the guy who is most likely to steal your watch at SecKC? No, not Bill. I'm number 2. What? Do you guys not remember? Gene. That's right, it's Gene. All right, with that, let's go ahead and introduce our next speaker. This is Caleb Christopher. All right, we're going to learn all there is to know. We're going to do a super deep dive into cryptography. Who of you looked at the SecKC website and saw Caleb's description? Did anybody decode that? Raise your hand. Don't yell it out. All right, well, I'm going to hand it over to you. Way to go. Go get him, Caleb.
Thanks, man. Start my timer here. Well, in case you didn't decrypt that, it's base 64. Go figure it out. It'll be fun. It's like a field trip, right? Do it on your phone right now. Okay, so one thing I want you to know right from the start, you're excited to be here, okay? Now, this is going to be a big deal. Those of you who are familiar with this clip will understand what I'm saying. This is actually not a deep dive. We're staying right on the surface of the issue, okay? We are not going to crack through the ice and get into the mathematics or any of that junk. I get headaches trying to read books about that stuff. I've got a certification about encryption. Dude, don't go there. Let's stay at the surface level, all right? This is an introduction. Very well. Okay, so what I want to do, I'm going to introduce, this is the problem, right? Cryptography is obviously the answer. But how do we use it? How do we get the answers? We've got 3 questions. How do you talk privately to someone in a crowded room? Let me hear some answers. How do you do that? What? That's right, different languages, right? So if I want to know how to have a private conversation with Bill. Bill, do you speak Croatian? No. Yes, for this example you do. Yeah. Okay. Does anyone else speak Croatian? No. Thank you. We're going to say for this example, no. All right, you following me now? So, Bill, now you and I can talk in an open room. Other people can hear it. They can know what we're saying without understanding it. That's how encryption works, all right? That's what I want to do. That's the problem we have to solve. Now we need to solve it in real life across the internet. How do you know that what you said or what the other person said hasn't changed, right? So if we switch to written messages and he has to write a note like in elementary school and middle school and pass it to me, we have to trust other people to hand that message across and all the way up here to the stage. How do I know that from the time it left his hands to the time it comes into my hands, it hasn't changed? That's one of the problems we're going to solve with cryptography. And then how do I prove who said what? How do I know that Bill's actually the one that sent that message? Right? These are the questions we want to answer with this talk. All right, you get into the definition stuff here, blah, blah, blah. Basically, I want to keep private stuff private, right? We can solve more problems like we just saw in the previous slide. But here's the exciting part. So Google has been tracking the use of the word cryptography since 1800. Okay? So that's 1800 right there. Right about there, really low usage, right? Not a lot of people talking about it. They want to send a private message, they walk down to their neighbor and talk. Okay, this is 1900. Right about here, there's a little plateau. So, during that plateau, I just Googled some stuff to figure out what was going on, just out of curiosity. Your mileage may vary, interpret it how you want. Interesting things. At that time, I found there was the Boxer Rebellion, the formation of the Irish Party, the world's first wireless transmission. That certainly wasn't encrypted, but maybe they were thinking about it. Maybe they searched Google. McKinley was shot, and the Socialist Revolutionary Party was started. So there's a bunch of relatively sensitive topics. Maybe it came up at that time. And then, in the late 1900s, we see this huge spike. Why? Any ideas? Wrong! A man named Bruce Schneer wanted to sell some books and get some speaking engagements, so he spammed the Google search results to make it really popular. He succeeded in his mission, and then what do you think happened right there? He retired. And then it dropped off sharply, and then right around the 2010s, we had the rise of Bitcoin and ransomware, and people are re-interested in cryptography, right? Now, if you don't know Bruce Schneer, you want a deep dive, go read one of his books. He is one of the leading minds in cryptography, okay? I was kidding. He's a respectable man. So, if you forget nothing else, or if you remember nothing else from this talk, what do we want from cryptography? Pain, that's right. Did you say it in English? All right. It's all about pain. P, privacy, confidentiality. A, authenticity. We want to know who said what, if that was really the person who said it. I, integrity. I want to know that the message hasn't changed from its original state. And N, non-repudiation. This is very closely linked with authenticity, but it's more of a legal concept. Again, guys, don't skin me. I'm staying right at the top of that layer of ice. We're not going down into the pool, into the freezing water. Okay, PAIN, what's it about? What's cryptography for, everybody? This is painful. Everybody say pain at the same time. What is cryptography? Pain. There we go. It is painful to study too. Okay, visual aids. Cryptography brings pain. That's a paintball gun on the right and a man in a shower. You want to talk about pain. Okay, we have some key terms here. I'm slapping myself in the forehead because I didn't put this in my speaker notes and I'm looking at a blank screen. I only have speaker notes on some slides. So, note to self. Plain text, this is the easiest one. It says what it is, right? A cipher. This is an algorithm with which you encrypt plain text. The ciphertext is the text that has gone through a cipher. We get what's called a message digest from a hash function. Now this is essentially a one-way encryption that's not meant to be reversed. Okay? Cracking, not the same thing as reversing. We're going to spend a lot of time on these two here because we want to solve those problems of communicating privately and maintaining. We want to achieve full pain, right? So, a symmetric key. This is synonymous with, you'll see all sorts of these, just know that they're all talking about symmetric key encryption, private key, shared key, session key, secret key. All 4 of those, 5 of those, mean the same thing, okay? Now, here's the thing with symmetric cryptography. That's me and Bill talking in Croatian. We both know what each other are saying. It's very fast and easy for us to speak a language that we know natively. Computers can do the same thing with encryption. The problem, anybody, what's the problem with symmetric cryptography? Distribution of keys, yes, sharing passwords, etc. Same thing. So how do I tell Bill what language to speak without any of you knowing? That's the problem. And that's a scalability issue for symmetric key encryption. Now, it is very efficient. That's one of the big benefits. Asymmetric cryptography. You'll see public key cryptography, PKI, public key infrastructure. This is what happens here is we generate a key pair. You have a private key, which you keep. Private, very good. And you have a public key, which you publish. This is counterintuitive to some people. Why would I publish my key? The way it works is something that is encrypted with one key can only be decrypted with the other key. So I want to publish a public key and let you encrypt things with my public key so that only I can decrypt that. That achieves confidentiality across an open medium. So let's look at it this way as an example. You there with the boxers. Yes, I can tell. You're my example person right here. So let's say you have an imaginary lockbox, and I have a padlock, and I chuck my imaginary padlock out to you, and you catch it without getting hit in the face. Now, you can write whatever message you want inside that steel lockbox, drop it in there, and then lock it with my padlock. And then you can have other people, your mules, carry it to me. When it gets up on stage and I unlock that box, I'm the only one with the key. Then I can read your message. Can anybody else read it along the way? Not for the purposes of our example, okay? Quiet you. This is a very simple illustration of how some asymmetric cryptography works. Now, the same is true digitally in the reverse. It's not quite the same in real life with physical lockboxes, right? But I can encrypt something with my private key that then anyone can decrypt with my public key. Why would we want to do that? Yes, because something that is encrypted with my private key can only be decrypted with my what? Public key. That means I must be the one who wrote that message. There's your authenticity. So, then we get some other terms. CIA, very common term, abbreviation, whatever you call those, in security. Confidentiality, integrity, and availability. We're always trying to keep those 3. It's a balancing act. And then we have PAIN. What's that stand for? P, privacy, authenticity, integrity, and non-repudiation. So, back to hashing. It's very similar to asymmetric, right? It's like half asymmetric cryptography. I can take a large file, put it through a hash function, and a fixed size block of text comes out that represents that file. If you change anything within that file, the output of the hash function changes. That's the purpose of hashing. So I can send you a file, send you what the hash output was, tell you what algorithm to use, and when you receive the file, you run it through a hashing function as well, and if it matches, bingo, you got the right file. If it does not match, then that has been modified or replaced. Again, symmetric key. This is not scalable. Sorry, I get mixed up on these. So talking up here. By the way, any one of you could have given this talk. All right? Just a couple of hours of study. So let's have some more talk submissions on intro stuff so we get more speakers up here. So, symmetric key achieves confidentiality, but not all the other stuff. It's fast, but it has problems with key distribution. Asymmetric. We achieve non-repudiation with this. We can. And it is very easy to distribute keys because you publish one publicly. Okay? Achieves full PAIN. All right, here's the quiz. As a team, I think I got the 3 questions. Okay, keep these in mind. Now, what's an everyday example of communicating privately over a shared medium? Sure? Web browser. Very good. Are you heckling me? This doesn't feel like heckling. I thought you were going to heckle me. I studied many years in the Amazon forest of retard to be ready for this day.
You might have overdone it.
All right. So if you have a lot of data to transfer, which one do you want to use? Which type of encryption? Symmetric or asymmetric? Symmetric, because you have a lot of data. It needs to transfer. It needs to be fast. If you're a web server and you have thousands of clients that you're connecting to and trying to talk with, which are you preferring, asymmetric or symmetric? Symmetric. Why can't you use symmetric by itself? What's the problem? Key exchange, key distribution. It's very difficult to get those out securely. Now, if Bill and I met privately outside and discussed we were going to speak Croatian or some other language, then we could do that privately, but that's not possible in a scalable fashion. So, how do we handle key distribution efficiently? We switch to asymmetric or public key cryptography. If we need integrity, non-repudiation, and authenticity, we need what? Asymmetric or symmetric? Asymmetric, public key cryptography. So what's the problem with asymmetric? This is just review. It's slower. Thank you. Now, so how do we get the best of both worlds? We use a little something called hybrid cryptography. Keep an eye on the colors here. Red for asymmetric. So a client obtains the web server's public key. Then that client uses the public key to encrypt a freshly generated private session key. What kind of key is that? Symmetric. So we use asymmetric to connect. We generate a symmetric key. We then send that over, that asymmetrically encrypted symmetric key, to the web server. And after that, we start using that as a session key. Why is it called a session key? It's in use for one session, and then it's discarded. So we just solved our problem. So, a visual representation. Step 1, you start with asymmetric. Step 2, step 3, profit. Remind me, one more time, what's the word? Why do we want to use for cryptography? What's it all about? Pain, privacy, authenticity, integrity, and non-repudiation. Thank you.
There we go. Okay. Hey, how's everybody going? Everybody drunk yet? All right. So we're going to give a quick talk about the B-Sides badge, the challenges that were built into it. So not very long. I'm going to run through this. If you went, it'll make sense. If not, it might make sense. Go next year. Yeah, go next year. Why the hell weren't you there? Jesus, $20. So, on the badge this year, we went with a couple different challenges. The first one we had was the beacon search and crypto. So with the beacon search, we wanted to use the Wi-Fi that was built into the badge. So we built in a simple scavenger hunt. We wanted to use Wi-Fi. We wanted to include the LEDs in the scavenger hunt. And we had 6 LEDs, so we had 6 Wi-Fi access beacons that you had to find. So basically, when you turn the badge on, it checked if you were at the conference and started scanning for those access points. And it would also save your findings. So we wanted to use a little bit of memory, kind of expand our experience with the 8266. And it will save to EEPROM. So if you found the first one and the third one and you shut your badge off, you don't have to start over with. First and third were still there. So initially when you turn the badge on, it had a Cylon kind of pattern where it would go back and forth and scan. After about 15 seconds, it would turn on the Wi-Fi and check for any of those access points that were around. Now we made the access points, we dropped the power on them as much as we could, so that you'd have to be within about 20 or 30 feet to pick one up. We also put some in lockers. I threw one in a bag in the back room. So tried different things to try to make it to where you had to search them down.
Who found all the
He didn't find one.
And then once it scanned, it would show you which ones you found. So you'd have LED 1 or 3 or 5 lit up. And then it would turn off the Wi-Fi and start the Cylon scan again. What we did there was using the Wi-Fi on the A266 uses up a lot of power. So we wanted to try to extend that power throughout the whole day or 2 days if we could.
Who had to get a second set of batteries?
You're welcome. And once you found all of them, it would go into a random blinky mode. Again, because we saved all those flags to the memory, if you turn it off, turn it back on, you still had it solved. So if you have a badge right now and you didn't find all the access points, real simple. Name an access point, Badge Pirates 01 through 06, let the badge find it, and then it unlocks it. We also had a factory reset, so we didn't do it. You're welcome. If you run an access point called Badge Pirates -nuke, it will factory reset and forget all your settings. So basically, it clears out the memory.
Somebody please do that, because I've seen some badges around here. You can reset everything right now.
Yeah.
I don't know. Code's on GitHub.
Yeah. And to cheat and win all of them, yeah, there wasn't one. We didn't build that in there, but you could. So moving on to the crypto challenge part, we had 2 crypto versions. One was a red herring. I know Sis Aaron, who's not here, cussed me out all day because he kept coming up with red herring as the decryption, which is what it was. The other one was a Gronsfeld cipher. So the Gronsfeld cipher was on the non-electronic badges. So we had 250 electronic participant badges plus 75 more speaker and sponsor and other ones. Those had the red herring on it. The 500 non-electronic had the actual cipher on it. And here's a screenshot of that. If you can't read that, that's actually the cipher right there. In case you want to write it down. Maybe try it later. There are, because we use a Gronsfeld, there are 2 keys, a numeric and an alpha. And those are both found on the badge itself in the copper layer. So they'll be embossed on the back of it. You have the number up there in the top left, 1337, right? And an underline of pirates. So basically, if you decrypt that encryption, you get an SSID and a password. That SSID and a password will give you access to an access point, which is currently running somewhere. And on that access point, there's a text-based adventure game. Complete that text-based adventure game, and you'll get information on how to come up to us and give us the phrase that pays. So we had one person solve this. We had one person solve this the first day. And I'm very proud of him. And that is that guy. So I want to bring him up here. Big hand of applause for that guy. We are going to give him one of our Uber badges, one of the pirate black badges. There were 5 of these made, so he's got one of them.
It is.
Yeah, thank you. So the challenge is still live, but you can't win that because he already won it. I want to also give honorable mentions to Sis Aaron there, far left, Archwick, Zilla, and X. McMillan
Yeah, so Sebastian, I think, is probably the only person still here.
So Sebastian, come on up. We got a consolation prize for you too.
So we'll put a picture of this out, but we did a challenge accepted, completed SAO specifically for these challenges. So we only had 2 of these. The first 2 were one for the counterfeit badge challenge, and then Arden for this. But we had these people. They locked themselves in rooms to do this. So
Yeah, they locked themselves in a room while everybody else was out partying and worked on this crypto challenge.
and if you can't tell, Ciceron lost his mind during this thing. He was.
So, on the badge, was there any more cryptos? Was there any more challenges on there? Maybe an LED sequence? Maybe the keypads or the traces spelled out something. Maybe, maybe not. It didn't. Sorry. Those were red herrings too. We threw some other stuff in there because we knew people would be looking at the LED patterns. So we tried to hint around that. And there is some traces on there. There's some pads that may or may not be used in the future. I don't know. So references. The crypto challenge, we have a website, cryptochallenges.com, where we have some crypto challenges up there that we've done in the past for SecKC. I have some 101s up there for different types of crypto analysis. So if you've never done any crypto at all, but you think it would be interesting, head to that website and try some of the 101s. I'm gonna have a 101 on a Groundsfield crypto and how to solve it. I'm gonna use this as the example of how it can be solved. And this write-up itself will be on blog.badgepirates.com, which can also be found on badgepirates.com. I want to go through the Badge Pirates credits. So we got Jiggle Billy and P-Core back there, our software developers. They worked on the software for the badges. Network Geek did the awesome kids badge. You got to see that. There was a laser tag, sharks with lasers on them. White Hat, Steph back there worked on the game design for the text-based adventure, and I did the board design and the talks. So, after the universe, thanks for staying for the credits, but we heard you guys love LEDs. 650 enough for you? No, 650 LEDs. This is just a sneak peek. Those white things are LEDs. So this is going to be our SecKC badge for DEF CON this year. Look on Slack, follow us on Twitter. We are going to have a pre-sale for SecKC members only for cost. I'll give you the code for cost of this badge. You'll get this badge. Or wait until it goes on sale to everybody and pay out on like 20 times as much. Because I'm going to retire after this one.
Bill only gets one at cost.
Geek real quick, he's got some requests from you guys.
Thanks, Kevin. Who here knows how to solder? Who loves to solder? Who's heard of Maker Faire? All right. So we got invited this year to build a Learn to Solder kit for Maker Faire Kansas City. So in the past, the Make organization has kind of designed their own Learn to Solder kit that has been used as part of Maker Faire to kind of teach people how to solder during the event. And this is our design for the Learn to Solder kit for this year. We've been asked to kind of help with running the Learn to Solder Village as part of Maker Faire. And we are going to have, we're doing a call for volunteers. So if you want to go to Maker Faire and you don't want to pay to go to Maker Faire, this is a great way to do it. If you volunteer for a shift, you will get into Maker Faire for free. So those shifts are going to be either 3 or 4 hours apiece. It runs on a Saturday and Sunday, June 20th and 21st, I believe. I will post a link on Twitter and on Slack for a sign-up sheet if you're interested. If you've never soldered before and want to learn how to solder and then teach people how to solder, we will do a workshop to teach you how to solder, how to unsolder, and help people troubleshoot their solder kits as well. So it's a great opportunity. If you've always wanted to and never have, this is an option for you to, or an opportunity for you to get those skills. So if you follow us on Twitter at Badge Pirates, or catch us on Slack. If you're even kind of just remotely interested, sign up. We'll get some communication out around this, and we'll kind of maybe follow up next month at SecKC. Thanks.
Just hit mute? Yeah, all right. What's up, guys? My name's Ryan. I'm with Def Security. I'm just going to quickly kind of recap the CTF that happened at B-Sides, the MUD CTF. I'm not actually the best person to probably be presenting this, but Dan is out of town, and so I'm going to be doing it. So some quick facts. The CTF that was at B-Sides was a MUD framework, which is like a multi-user dungeon. The whole design and kind of idea was all Dan's thing. It was just kind of a twist on normal CTFs where instead of doing the Jeopardy thing, you know, have this like dungeon you crawl through and you find different challenges as you're going through. It was a team-based CTF. The challenge categories we had were crypto, forensics, mobile web, Stego, phoning, reversing, programming, and then some miscellaneous ones we couldn't really categorize. And then there was actually real-world hacking ones where if you went to any of the villages around B-Sides, you could also earn some flags at the different villages. All the in-game challenges were done by like the depth kind of crew. A bunch of us just contributed different stuff. So the scoring breakdown. So overall, there was actually 50 possible flags. The total possible points was, I think that's 2,970,000. I think that's right. 21 teams scored at least 1 point. The top team was Trust Foundry with 872,000. The most flags, they were actually tied with SecDSM for the most flags at 18. And of challenges solved, 31 of the 50 possible challenges that were in the game were actually solved. And then that bottom little chart is just the teams and how many different challenges they solved. And on the right side is all the scoring breakdown. And by the way, at the end, it was kind of a cluster. I wasn't actually there, but at the end, I guess it was a cluster. And if you were on one of those top 10 teams and didn't get your prize bag or something, just come talk to me after, because I think not everyone got their stuff. But just let me know. The flag values, we can post that stuff if you want it. I don't know if it really matters. The top 5 most solved, Stego 1, Crypto 1, Reversing and Pwn in Web 2, which I don't know why Web 1 wasn't more, but I guess that's how it worked out. And I will just quickly kind of show you guys what these challenges were like. Even though it was like a MUD kind of dungeon design, you still kind of popped out a lot to web challenges or crypto challenges or whatever. So challenge 1, this was the most solved challenge, was a simple Stego level 1. This was a file that you found that would be hosting on a server. It was this little critter. I don't know what that is actually. The best thing to do with these when you first get one is to check out the EXIF data. This one was pretty simple because once you put this into like an EXIF viewer, the description of this image was actually the flag. So pretty basic one. Quite a few people solved it. And so next time if you ever play, something to look for. The next one I was going to cover was Stego 2, which there was only 2 people that solved. So you came across a note that had this text on it, which is just, it doesn't quite make sense at all. It's kind of an out of order looking sentence maybe. The hint was it's a 9-sided circle. I I don't know if that hint's completely good, but it's good enough, definitely, once you figure it out. And so, 9-sided circle, you can kind of see, just because you know the flag formats are going to have those brackets, and it's going to have flag in there, you can try to figure out how you can make the word flag with a bracket. The 9-sided circle was a pretty big hint, because if you take the 9th letter, every 9th character in the string, you can see that it starts to spell out flag there. And so if you loop through this entire script, or text, you can find that. You can actually do it with a simple little Python one-liner, just to print off the 9th character. And if you run that, you'll get the flag that Walker Nearly Bachelor Teacher stood. But a little bit tougher, and not a lot of people solved it. So just something to look for next time you play. We had 19 challenges in the game that were never solved. So we'll just save those ones for next year, I guess. That's nice for us. We made a bunch of these challenges. And lastly, one of the challenges that wasn't solved is actually still posted on our Twitter. If you go out, there's an image there, and if you look at it, something clearly looks a little off about that image, the little shot of the KC skyline. But if you go to the Twitter page, you can download that image. If you solve it, message me on Twitter or Slack or something, and we've got prizes that we still have left over from the CTF anyways. And if you still want to solve it, send me the flag. It's in there. Good luck with that. And that's all for me. And if you have any issues with the CTF or questions, come to me afterwards. Dan's out of town, but he would probably have actually all the answers. Yeah. All right.
Thanks, Ryan. Good job.
Thanks.
You did a good job on the CTF.
Thank you.
All right. Well, ladies and gentlemen, that concludes May's SecKC. See you next month. It's always on Patch Tuesday.